Okay, in this derivative, we're going to talk about antidifferentiation. Up to this time, we've been doing derivatives. Now we're going to work backwards. So, for example, if your function, so let's start out, this is 6.1. If your function was initially, let's just say 7x plus 3, and I said, like we normally do, take the derivative of that, you would just get 7. What if I said work backwards? So if I said, okay, I want you to take the antiderivative. Taking the derivative is working this way. Taking the antiderivative is working that way. Is there any way that you would know, looking at this derivative, that it came from this? Well, think about that. You could probably figure out that you had an x associated with the 7, but you would never get the 3. So for that reason, you have something called the constant of integration. So let's go and do some problems with constant of integration so you get the hang of it. All right, here's our first problem. So I say find the antiderivative of f of x equals 6x squared plus 3. So a note about notation. They're going to write their derivative as small f of x. So I know that's odd, so just know that that's what the notation is they're using. They're going to write their antiderivative, which is the original function, as capital F of x in this section. So let's figure out, how will I find the antiderivative? Okay, so this is the pattern we're going to follow. Write your 6 down, write your x down, add 1 to your exponent. You had a 2, make it a 3. Divide by that same number that you resulted in for your exponent. Add the constant of integration. Okay, let's see if we can get, if we take the derivative with respect to x of f of x, do we get back our little f of x? So let's see. 3 times 6 is 18, so 3 times 6 will be 18. Raise this to the second power. You still have the 3 there, which you need, and then the derivative of a constant is just 0. Okay, so these are going to go, and the constant I can't really guess, so I'm going to add that c so that I can take account of that. So you can see that following that pattern of adding 1 and dividing by the same number that you have up top is going to get you what you need. So let's try to get a generic pattern. So we'll do that on the next slide. On the bottom of your first page of notes, this is what you see. If your antiderivative was x to the r, what is your original function? So let's follow our rule. So if my antiderivative was x to the r, then add 1 up top, divide by 1, and add the constant of integration. That's our general rule. Now this works for all your powers, except it does not work if r equals -1. So we'll talk about that in a minute. So let's go to the next slide, and we'll use some different notation. Okay, in this slide we're going to introduce the integrand symbol. So here's your integrand symbol. This is telling you to take the derivative, to take the antiderivative, and it's telling you that your antiderivative was, or your antiderivative was 3 dx. Okay, what was your original function? So you're going to add an x. You didn't have a power, add the first power, plus c. This tells you to take the antiderivative. So go back. This would be your f of x, which is your first derivative, and this will be your capital F of x, which in our notation is the original function. Okay, other rules. What if you had this? So I have x to the -1. You always have to say how you took the derivative with respect to x. and I tried to use our rule. So add 1, I get a 0. That's okay, that's just 1. Divide by 0. I can't do that. So because I can't do this, this rule does not work, as I said in the other slide, if your power, if your r is -1. Why is that? What is the derivative? Or what is the original function? So let's think about that. I'm going to write this somewhat differently. What if I write this as 1 to the x dx? What derivative have we taken lately that 1 to the x was the answer? So you should be yelling at the video at this point, oh, that's natural log of x. That's right, it is. So let's do another natural log. What if you had this as your answer? What's the question? What was the original function? 7 natural log of x plus c. Okay, we're going to go over a couple of more rules on the next slide. We've done e's lately as well, so natural log and e work together. So if I ask you to take the antiderivative of e to the kx, your original function would have been this. So let's check this out, make sure this works. So what I'm saying is, if I have e to, let's say it's the 8x, and I want to know, and I should have put a dx here, so I'll put a dx there. I want to know what was the original function if this is my first derivative. So the rule is this. Write down what you see. Normally, if you're taking the derivative of this, you would have multiplied by 8. Because you're taking the antiderivative, you're going to do the opposite, and you're going to divide by 8. And then don't forget to add the constant of integration. All right, and there's one other thing I want to do. We'll do that on the next slide. All right, so the sum of integration is, you can divide it up just like you did when you had derivatives. So if you're trying to do the integral of a sum, you can instead do the sum of the integrals. So let's do a quick example. If this was 1 over x plus e to the 7 x, and I have a dx here, of course, what would the antiderivative be? Well, I can take 1 over x dx and add it to e over 7x dx, and doing that I would get natural log of x plus e to the 7x over 7, and then just only add one constant of integration. You don't need to add multiple constants of integration when you do a sum. All right, one more slide and we're done. Okay, what if you had you're supposed to take the integral of a product. You don't know how to undo the product rule, so your first step would be to use your rule of exponents, combine your powers because it's multiplication, so that's going to be x to the 7 dx, and now take that antiderivative. So that would be x to the 8 over 8, following our rules, plus the constant of integration. All right, so that's an overview of your 6.1. Now you can go ahead and try to do some sample problems.